Good morning, Michael.
Good morning, Sam. Now, Sam, have you ever tried to do something with the wrong equipment? Like for me, often I will need to unscrew something and I'm too lazy to go downstairs. So I use whatever I have in front of me. Car keys, maybe a credit card. None of them work. And then I have to then be like, fine, I'll go downstairs and find a screwdriver. I feel like you would get the right tool for the right job every time.
Usually I try. What immediately came to mind was last Discover Barcelona, I brought our editor some food very late at night, and I also hadn't eaten. But I forgot to bring utensils, and so we had to make do with what was around, and those were wooden coffee stirrers. So we ate trying to use them kind of similar to chopsticks. It was not very effective, but we did at least eat.
I've definitely done that before. And it's now why I have wooden cutlery in the glove box of my car. Anyway, as you know, sometimes something new comes along and suddenly everything that came before it has to change to keep up with the times. And as per this episode, even the way that we design our technological infrastructure. It will all make sense, I promise. I'm Michael Bird.
I'm Sam Jarrell.
And welcome to Technology Now from HPE. Now, Sam, AI hasn't just changed how we interact with our technology. AI itself interacts with our current technology infrastructure in a completely novel and different way.
And it's literally forcing us to rethink how everything is designed, right?
Yeah, exactly. AI has a set of quite specific requirements, which means that the network architecture required to support it has to be completely different to what came before. AI doesn't sleep, and the data needs to be kept live to give accurate results.
Those have come up several times in recent memory. So I guess with all of these new requirements and the explosion in AI usage, we are having to respond rapidly and create new ways of designing networks.
Exactly, Sam. And these changes come with a level of urgency for organizations because AI infrastructure isn't cheap, and if it's not being used to the best of its ability, it can then be a huge waste of money. So, to find out more about how our network architecture is adapting to the age of AI, I spoke with A.E. Natarajan, SVP General Manager for Routing Infrastructure Solutions, HPE Networking. And first things first, I wanted to get an overview of the topic and just define what network architecture actually is.
Essentially is the way you build networks to interconnect. And there are different parts of the network. There are core networks which interconnect globally. There are edge networks. There is access networks where you bring in customers. There's aggregation networks that you have. And then there is networks in the customer premise. There is networks in the data center. So architectures vary with each one of those things. Some of them have similar architectures. Most of these networks are built for scale, connectivity, growth, and ability to adapt to new things that come about.
Can you sort of paint me a picture what the sort of traditional pre-AI network architecture looked like, and maybe a bit of a sense of like how long it's been like that for?
It traces back in history, if you really want to go through it. Towards the late 90s, early 2000s, we called it the internet boom. And the whole idea behind that internet boom was to try and get everybody online. It's not just people, it's things, people, IoT, all of those devices. And then we embarked into a different era in networking, which was cloud. Previously, we used to have client-server-based applications. We moved over to cloud, where the applications actually got pushed into a cloud because the applications demanded dynamic compute and growth. And cloud was an easy way to actually push that over to the cloud so that your applications can actually grow to the dynamic demands and growth. And then we said that was not enough. Not just you move the applications around in the network and globally. I'm going to move the users around. And then we brought mobility into place. So users were actually moving around. So network architectures had to adapt to all of these things over the periods of time. And then last but not the least, we brought in AI. And this AI brought some interesting elements into the network, which is what I think we should be discussing.
When we talk about sort of traditional network architecture, we talk about how there's different peaks at different times in the day. Can you sort of talk through that in a sort of typical organization?
Let's assume that you were in the age of the internet or the cloud. and you had a SaaS service or a streaming service, and you wanted to do something about it. You wanted to watch a movie, you wanted to watch some recording, you wanted to watch something pulled down from there. You would send a small pile of bits over to the server side or to the cloud application, and it'll stream a huge amount of data to you. So the data was asymmetric, pretty much. And the network architectures catered to that. Your upload speeds from the consumer was always less than the download speeds that you would get from consumers, and they would rate themselves based on that. They would always say, hey, you got 10 megs of download or 1 gig of download or something like that, but they never talk about the upload speeds because it was always meager. Then the second aspect of it is we used these networks to multiplex. Not everything was on at the same time, so you would actually multiplex it. So you would use your network resources effectively to redistribute the load where it's needed and shut off load if you don't need it completely to save time, energy, and money and whatever else that you can. So we built network architectures that did all of these things. But that used to be in the cloud and mobility era. The main challenges with the cloud and mobility is now, unlike the client server, you could no longer predict where data is coming and where it is going. It was still in terms of upload being small, download being high, but with mobile users, they were traveling and they were moving around. So they would trigger from different places and downloads had to cater from different places. Applications would move with the sun. So you would have to change where the applications were getting loaded or microservices or SaaS-based services were getting loaded. So you would do all of those things in a cloud environment.
So let's talk now the sort of post-AI world, which we live in now. And I suppose you'd probably call it an AI native network. What does an AI native network look like, and how does that differ to a traditionally architected network?
In the case of AI, whether you're doing ingest for training purposes or you're doing inferencing, you're sending rich content upwards and you are downloading rich content because you could be using AI-based glasses or virtual gaming machines and things like that. You were sending rich content upstream and you were delivering rich content downstream for what you were doing. So the AI started superimposing symmetric data patterns in traffics. The second aspect, what AI did was it really created a notion of agentic AI, where the person is no longer there and agentic AI is running all the time, every time, which means the data never has peaks and valleys and you can't multiplex, you can't actually load balance across different things. And you had to actually have a network that is provisioned to handle this load constantly every time. The last thing that AI did, which we didn't talk about in the streaming service, is when you streamed the service, if it was coming from a distant place in the network, it would say buffering and you would get really irritated. So we started building caches towards the edge. But with AI and AI data, you no longer can build it with caches because AI data gets obsoleted the moment you try to cache it. And so the network architectures have to rethink the way we do stuff in AI. Network is symmetric. The network is always on, and the network is not cacheable.
Caching in a traditional network is quite a crucial way of saving bandwidth. We're saying in the sort of post-AI world, can't really cache things because every request is essentially unique.
Correct.
So these networks run 24/7. How can you ensure they're being used efficiently? Because presumably if you're running your network 24/7, or if you're architecting a network to be running 24/7, that's potentially more investment in terms of equipment, in terms of power, energy. So how do you make sure actually that it's being used effectively?
You hit upon something very interesting. AI is automatically a distributed element. We all know that a single GPU does not carry the AI workload. So you have to build clusters of GPUs to do AI. Now, with power and space constraint, you can't put the clusters geographically located. It has to be distributed. And we talk about AI build-outs that scale up within a rack of a data center, scale out within the data center, interconnecting all these GPUs within the data center. And now we're talking the third dimension of scale across geographies, where the network elements and the network pieces have to actually tie in and build the scale across. And you bring a very interesting point here about scale across, where when you're scaling across or you're scaling up or scaling out in the data centers, you need to make sure that the GPUs are constantly being used and delivered their ability to compute. If they are waiting on data or they're waiting on the network to give data, then you're losing cycles on the GPU. And those are the most expensive things. You need the ROI for it.
So AI lends itself quite nicely to distributed network architecture.
Correct.
And it performs best, in fact, with a distributed network architecture.
Absolutely. It performs extremely well in distributed architectures. And AI, by nature, is very distributed, and it renders itself for the distributed architecture.
So it's about every step along the way, really thinking about how that piece of the network is designed, how it's connected together, what hardware's there, because you don't want to put bottlenecks into the system.
Absolutely. So you have to really architect the system so that you have to build this in such a way that it is efficient at every stage of the network, so that you get the maximum benefit and the maximum ROI of the large investment that people are doing with AI.
Why don't we just move all AI infrastructure to the edge?
I just talked about the factory, right?
Yeah.
You still have to do training. You still have to do certain things in the factory to build from raw materials to goods. So you have the data coming in and you have models to train. You have to do all of that stuff that goes into the center of the factory and generations of it. And then you have to also scale it up so that the edge becomes intelligent, the edge architectures become intelligent, so that the end product gets delivered in a very quick fashion to the end user. So the consumers, when they look at it, when they're consuming AI, which is where the biggest thing is, the user experience really matters. So you want the edge to be there with the capabilities to deliver the lowest latency, predictable response times for anything and everything that you do. And that is important, as well as the rest of it in the core for building it and doing it is also important. You cannot move everything to the edge.
So as AI continues to grow, what's the most important piece of advice that you can think for organizations, service providers who are adopting this sort of AI native architecture into their systems and infrastructure?
When you look at it as a service provider and you look at these products and solutions, there are multiple aspects of this AI. First and foremost is the products and the solutions and the architecture that you build is most efficient in handling inter-GPU communications or the data center interconnects so that the GPUs can work really, really efficiently. Second, on the edge, your architecture is defined in such a way that the consumers have a user experience that is really good and have an excellent experience. Last but not the least, it is constantly growing. You're going to get the next generation of GPUs and the next generation of applications and the next generation of agentic AI that is going to impose more and more demands and throughputs of it. Can you build a system that can seamlessly migrate from one step to another and provide you that longevity? Good. We actually announced those products that today, which are 800 gig, can easily move over to 1.6T and above. And that is huge. So when you are an operator, whether you're a service provider who is transforming the edge to deliver it to your enterprises and customers, or you're somebody else who's building models and training models, or you're providing that service to your enterprises, you need to think about the network architecture, not just for today and also for tomorrow. And think about what AI imposes to you. It is always on. Both the upstream and downstream is going to be symmetric or huge loads. And you cannot cache it. You cannot cheat the system anymore.
A, thank you so much for joining us on Technology Now.
Cheers.
I really enjoyed chatting to A, and I always find it fascinating talking about topics where you come away thinking, I never really thought about that in that way before.
I appreciated the walkthrough on the evolution from internet cloud mobility, because it kind of does show how they've always adapted and changed over time. I kind of figured it was all relatively the same, just with improvements. But I found it really fascinating that when you were talking to him about why not just move everything to the edge, right? That he said, we can't move it all to the edge in one shot. He didn't say, though, that it couldn't be something that happens in the future. And I wonder if maybe in the future, if that will be the direction that things go. Because when he was discussing about it, he was talking about the user experience and that users are consuming AI. And so then they need to have it be a positive user experience. But I wonder if someday it could be an agentic AI at the edge and then it's interacting with another agentic AI. And there's no need for that user experience.
That's really true. And just touching on what he said at the top of the interview about how the way that we think about networks has changed. Like, what I took away from that is it has always been changing. Our networks have had to react to the internet boom, the rise of cloud, mobility. I remember during the pandemic, the way that we thought about our networks had to change essentially overnight. And I wonder if we're now at that stage with AI. But the thing that I thought was really interesting was caching. If you're accessing a website, stuff gets cached, so the end user isn't pulling that down from a network every single time. But the fact that you can't do any caching with AI, because essentially the data that you're accessing is brand new every time, because you're putting a new request in every time. The load on your network and the way that you have to think about your network, I just found that so fascinating that actually, yeah, you really have to think about this in a different way.
You're right. Caching has been around for decades, and it was sort of a clever way to save bandwidth. But with every request being like unique and instantly obsolete, I'm wondering if that sort of explains why AI workloads feel so expensive so quickly. AI wants a naturally more distributed architecture, and the GPUs don't work alone. So it makes sense. The workloads have to scale up and out across all the geographies. This entire conversation kind of brought me back to prior episodes where they've talked about, in regards to networks, how up doesn't necessarily equal good. And I feel like that maybe applies here.
Yeah, and like an end user just expects a network to work, don't they? And, I guess we talked about how our organizations are having to adapt to AI native architecture for their networks. But for the, everyday person, this is something that affects us too. So the final thing I wanted to know from AE was actually, how will we as consumers experience this change?
You're holding a tablet. I have a smartphone. We are all using all sorts of devices, and we're going to be consumers of AI, and we're going to use AI in our work, in how we play and how we entertain ourselves and how we do things. And we could be doing things of training models. We could be using AI to do our work and getting answers. There has to be a consistent way by which AI responds to us and gives us predictability in terms of how it operates, so that the user experience is enhanced. Which goes back to all of the things that we talked about in terms of network architecture, transformation in the core, transformation in the DCI, transformation in the edge, so that you can deliver AI in the best possible user experience. And we need to think about it, and we need to also think about the growth. When this explodes and inference is taking on, it is going to grow exponentially. So we need to think about how these networks are going to just multifold grow in the next few years. People even talk about 5x growth in the next 3 to 5 years. So that is what is upon us.
Okay, that brings us to the end of Technology Now for this week. Thank you to our guest, AE Natarajan. And of course, to our listeners, thank you so much for joining us.
Yes, and if you've enjoyed this episode, please do let us know. Rate and review us wherever you listen to episodes. Don't forget to subscribe so you can listen first every week. And if you want to get in contact with us, send us an email to technologynow@hpe.com. A subject line. Any ideas, Sam?
Can't cache.
Can't cache. No cache. Technology Now is hosted by Sam Jarrell and myself, Michael Bird. And this episode was produced by Harry Lampert, Izzy Clark, and Eva Higginbotham, with production support from Alicia Kempson-Taylor, Zoe Revis, Becky Bird, Alyssa Mitri, and Janessa Ayosh. Our theme music was composed by Greg Hooper.
Our social editorial team is Rebecca Wissinger, Judy N. Goldman, and Jacqueline Green. And our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Fresh Air production for Hewlett Packard Enterprise, and we'll see you at the same time, the same place next week. Cheers.
Bye, y'all.